Hello, let's see the configuration of OSPF for IPv4. OSPF is Open Shortest Path First. It is a dynamic link state routing protocol, and let's consider this topology. This has four routers, three of them are connected to a LAN each and one is connected to a web server. Let's see how to configure the PCs and the web server with IP address. So when we click on PC, we go to this screen and when we go to IP configuration, we can give the IP address, subnet mask and default gateway of the PC over here. The default gateway for this PC is FA00 interface of R1, and similarly every PC has its own default gateway through which it can go out of the network. And this web server, when we click on this and when we go to IP configuration, we can configure the IP address, subnet mask and default gateway of this web server over here. Now the default gateway for this will be FA00 interface of R4. It may not be FA00 all the time, but it's the interface that belongs to the same network. Now let's see how the routers are being configured with IP addresses. So to come from the beginning, this is the user execution mode, and when we give the command enable, we go to privilege execution mode. When we give the command configure terminal, we go to global configuration mode. So since show commands can be issued only from the privilege execution mode, let me go to that mode. And now from here, if we give show running configuration, this command when we give, we can see all the configurations that have been done till now. So yes, now for this router R1, all these configurations have been done, and if we see this, it says interface fast ethernet 00, which means for this interface these configurations have been done. So IP address, and this is the IP address of the interface that's been given, and this is the subnet mask for the interface, for the network actually. So similarly, every interface of the router is being configured with IP address, and in the same way every router has to be configured. So after this, what we do is we configure OSPF. So for configuring OSPF, the command is router OSPF and process ID. So after giving this command, we need to give the network command. So network command goes like this. It should be given as network, then we give the network address of the directly connected network for that particular router, and then we give the wildcard mask. Wildcard mask is actually the reverse of subnet mask, and then we give the word area, and then we give the area ID or area number. Since this is a single area OSPF, we have used only the base area, which is the area 0. So all the routers and all the commands for OSPF configuration will be carrying only the area 0. So similarly, OSPF is configured for every router by giving the directly connected networks, network address and wildcard masks and areas. So after this configurations are done, let's look at show IP protocols. So this says a few details about the OSPF that's configured. It says OSPF1, which is the process ID, and a few other information, and routing for networks. It says all the directly connected networks which have been given in the network command of OSPF when we configured. And now when we see routing information sources, it gives all the source routers which has given routing information to this particular router R1. So when we issue show IP route command, we can see all the routes that are known by this particular router R1. Now when we see this router R1 has three directly connected networks. One is the LAN and the other two are serial links. So all those three networks will be listed as directly connected with the character C. And all the other networks whose information have been known by R1 through the other routers via OSPF will be listed as O. Now there's one more thing which we configured when before doing the OSPF. That was I'm sorry. Now in the router R2, a default static route has been configured. When we see show running configuration for this router, we can see that a command called IP route. Here we see IP route, this line has been configured. So this is IP route, and this is the IP address, and this is the subnet mask, and this is the exit interface. So this is a static default route. When this command is given, for a particular router. Say for example for R2 we have given this. So what happens is any packet that comes to this router with a destination that it does not know, it forwards it through the interface that was specified with the default route, the static default route. So here this interface has been given as the exit interface. So whatever packets come with the destination that is not known by R2, it will be forwarded through this interface. Right now this area is considered as internet for our experiment, so we have configured this as the static route. Now there is also one more command which we gave after giving the static route, that is default information originate. If we can see along with this OSPF configurations for R2, we can see that default information originate is given. This has been given so that the static default route that has been configured for this router will be carried along with the OSPF updates that are sent to the other routers. So when we see show IP route over here, show IP route, we can see that a static default route has been listed like this as directly connected one. But when the same thing is seen from R1 or say R3, we give enable and then we give show IP route. We see that the same default route is specified with the character O, which means it has been carried from some other router via OSPF protocol. Now let's see a few other troubleshooting commands. Let's see show IP route OSPF. This lists all the routes that are learned via OSPF by the router R1. This is actually a subset of the result of show IP route. Whatever routes are known by R1 only through OSPF protocol will be displayed over here. Then if we check the troubleshooting command show IP OSPF neighbor, we can see the neighbor routers of this R1, the neighbor OSPF routers of this R1. So we can see that this is actually the router R2 and this is actually router R3. So let's check whether we are able to connect from one PC to the other. Let's go to the command prompt, and if we say ping, for example, if we consider a PC2, the address is 172.16.2.2. So we see that we get the replies. So we are able to connect from PC1 to PC2 through ICMP protocol, and since ping uses ICMP. Now if we try to connect from the same PC1 to PC3, you can see ping 192.168.1.2. We didn't get the reply, so it is seen that we are able to connect to the PC3 from PC1 via ICMP. Now if we try to connect to a web server, we can try giving the IP address of the web server inside this, so that we will be able to see whether we are able to connect 64.100.1.2. So when we say go, it gives the result. So which means we are able to connect to the web server from the PC1. Similarly, if we try from any other PC to any other end devices, we will be able to connect. For example, I'll show one more example from command prompt. If we try to ping the PC2, which is 172.16.2.2, we are able to get the reply. So we are able to connect from all the end devices to the other end devices. Thank you.